Hello, I'm Guy, and this is Guy Robot. Hello! For those of you that follow my channel regularly, you'll know that I've been planning on moving to Linux as my main operating system. I've been umming and ahhing about what to do for it, and I finally decided I was going to go for Gentoo Linux with ZFS. Now I'm going to do a separate video on why I eventually came to that conclusion. But it was quite an interesting experience getting ZFS on an NVMe SSD as my boot device working in Gentoo Linux. In fact, I managed to completely mess everything up the first time I did this and have to start the whole thing again once I'd learned a few lessons from it. There is a really good tutorial by Feared Bliss, who is the maintainer of ZFS on Gentoo. I had to make some tweaks though for the latest version of Gentoo and also for my NVMe disk in order to get all of this working correctly. So I thought I would just do a bit of a tutorial talking through how to get this working. Now this is quite long, it's about an hour end to end with all the long running tasks cut out of it. So I've split this into two videos. In this video, which is the first of the two, we will get as far as having our own kernel compiled because yep, that's right, we have to compile our own custom kernel to do this. The second part of the video, which will be online next week, runs through once we've got that custom kernel, creating our own init ramfs in order to actually boot our ZFS disks and getting everything finished off. Hopefully you'll be able to follow this end to end. All the instructions for this as well are in the blog post that accompanies this. Every video I do has an accompanying blog post, so please check it out, guyrobot.tv. All the links, the download stuff, any other information, and every command step by step is in there. Apologies for the state of this office. I've only just moved into it. I haven't even finished it. As you can see, there's mould on the walls, which probably means my sound isn't terribly good here. And unfortunately, it means that when I was recording this video, I had to just capture it using my camera pointing at my monitor, as I didn't have any other way to do it. But that being said, all of these instructions and all of the commands are in the blog post that accompanies it. So if some of them are not fantastically captured, please do check out the blog post that's with it as well. Let's get going. So to get Gentoo up and running with ZFS, I'm going to follow a modified version of the Install Gentoo Linux on ZFS tutorial written by Jonathan Vasquez, who is the ZFS maintainer for Gentoo. I've already done a test run through this, and there are a bunch of things I had to change to get it working on my system, particularly because I've got an NVMe SSD disk. And there's also a few things I learned from this, so let's get going. The first thing is you need to download the System Rescue CD, which includes the ZFS drivers, and you can get that from the link in the video below. Put that onto a CD or to a memory stick, and the first thing you've got to really make sure you do is you boot that in UEFI mode. If you choose to not boot that in UEFI mode, you're going to get a bunch of issues later on. So rather than the blue pretty screen, you should end up seeing this one for your boot menu when you've selected it. If you can't have UEFI, you're going to make a whole bunch of changes to what happens in here. This guide is for a UEFI installation with GPT disk partitioning. So the first thing to do is to boot into it. I've made sure that I select disable kernel mode setting on the System Rescue CD. That's mainly so that this monitor that I'm filming works okay. If you have any problems that your monitor disappears, then it's also worth doing this to make sure that you're not installing other stuff you don't need for the installation process. So we're going to press enter now and start it up. So while this boots, how Gentoo Linux installs is you have another install of Linux, and then you pretty much do all of the work in that one and manually install everything that you need for Linux installation. So we're going to manually set up partitions, get everything ready that we need for it, and then get ZFS up and running. So we get prompted to enter a key map during this boot up, which just makes it a bit easier. We select that, and then it carries on and boots into a system recovery Linux system. There is a CD you can use as a minimal or live CD version that's available on the Gentoo website, but it doesn't include ZFS and a couple of other things. I don't think it includes NVMe either. So there we are now into our system. So what we're going to do, first of all, is we're going to just check that my block devices are found. So we can see there we've got NVMe 0 and 1, which is a 477 gig SSD, which is good because that's the one we're going to use. So you need to remember the name NVMe 0N1 or whatever you're going to install to on your system. Best to do this first before you start deleting stuff and realise you've done it on the wrong partition. The other thing I find it useful to do is do an IP address and just check that all my network cards are there and that I've got internet connectivity on at least one of them, as there's going to be nothing more annoying than having deleted my partitions and then not having network connectivity. I speak from experience. So the first thing we need to do is actually set up our partitions. So we're going to load parted with optimal partition boundaries on our NVMe drive that we found. And then we're going to tell it that we're going to use megabytes for our units for everything. So the first thing we're going to do is wipe the existing disk. It's important to know that as soon as I do this, everything that's on the current disk will be wiped, and there is no recovering it, there is no staging, unlike there is in some other partitioning utilities. Once that's done, we can start creating partitions. So we're going to have a tiny boot partition to start with, which goes from the first megabyte of the disk to the third megabyte of the disk. We're going to have another partition that goes from the third megabyte of the disk to the 103rd megabyte of the disk, which is going to be used for boot related things again. Then we're going to have another one that goes from 103 meg to 603 megs. That's a 500 meg partition, which is going to have all of our kernels and RAM disk images. Then we're going to create our swap partition, which is going to be 40 gig, which covers my 32 gig of RAM plus a bit extra because it never hurts. And then finally we're going to take up the rest of the disk from 4603 to the end of the disk for our main partition, and we're going to then give those a name. So we're going to call the first one is going to be for grub, the second one is ESP, third one is going to be boot, fourth one is swap, and fifth one is going to be the root ZFS pool that we're using. Once that's done, set a couple of flags. So we're going to set the first one to be for grub, and we're going to make the second one bootable. We can then check that all looks good. You should end up with something similar to that, depending on the amount of disk space you've got available. Then we can quit, and that's done. The first thing we need to do then is actually make the EFI partition formatted as FAT32. We have unfortunately no choice about this one being FAT32 because that is the EFI standard. So NVMe 0 N1 partition 2 that we just created, that is going to be FAT32. Now we can actually start creating our Z pools. So although ZFS is probably best explained outside this video, very basically ZFS is an awesome file system which originated back in the days of Solaris, and it has a bunch of cool features from encryption to deduplication to massive amounts of resilience to compression built in, and it just works really nicely for a lot of the things I want to do. Also works well for snapshotting, for sending things to offsite backups. So that's one of the main reasons I want to be using ZFS throughout my system. Now, a Z pool is a selection of disks or partitions that are put together for a particular purpose. Within Z pool, there are datasets which can be considered to be more like traditional partitions or block devices that you can use. So what we're going to do first of all is create the main Z pool. So we do Z pool create, we put a bunch of options in, which won't go through explaining all of them now. The only thing worth mentioning is this is going to have basic compression. If you saw my video on my NAS, I did a bunch of testing around this and it didn't make any noticeable difference to slow down, so I'm happy to live with that. And then the only other thing that's worth noting is for now, we're telling it that this is going to be on /mnt/gentoo. We're actually going to put it, obviously, in the root / directory eventually. But for now, so we can access it, we're going to mount it in /mnt/gentoo, and then we give it dev NVMe 0 N1 partition 5. Then we're going to create all of our different datasets. So ZFS create rpool/root. We're going to have the root mount point to be on that /root that we just created. And we're going to do the same again for the home directory. And then we're going to do the same again for the root home directory. Next we want to create the Z pool that we're going to be using for the /boot. So the reason we're doing this with two separate Z pools rather than just having one that covers everything is because Grub currently doesn't work with a bunch of the advanced features of ZFS. So instead we're going to create a basic Z pool, and then we're going to create, which is going to be for our boot one, which we're going to do now, and then we've already got the slightly more complex Z pool with more of the advanced features that we've just created for everything else. So it's just to stop Grub potentially breaking. So F. Then we're going to create our swap device, so swap on dev NVMe O N1P4. Then swap on dev NVMe O N1P4. And now at this point we should be able to do a Z pool status and see that we've got two Z pools. We've got the boot one, which says that it has some features not supported, we never want to upgrade that, as that will break grub. And then we've got our main RPool, which is sat there. We can do a ZFS list to see the datasets that we've created within it. So we can see we've got our home, root, everything's looking good. With that done, we're now ready to actually get in to the partitions we've created and start installing things. So if we do /cd//mnt/gentoo, where we've just installed stuff to, it's fairly empty at the moment. So we literally just have a bunch of empty folders for all the things we've just created. Now we want to create the boot/EFI folder, which is where we're going to have the EFI partition mounted, and we want to mount that now. So /dev NVMe 0 N1P2 that we created, and put that in boot/EFI. Then the next thing we need to do is download something called a stage tarball. So Gentoo works via 3-stage installation process. Now stages 1 and 2 aren't really used for general usage. The idea is that each stage has progressively more things on it to make it a minimal system, and the Gentoo stage 3 is probably more minimal than the overwhelming majority of other distributions that are out there's minimal installations. It comes with just enough tools that you can start compiling things and start installing packages from source. So the first thing I need to do is get that stage 3. Now you can get this from the internet, from Gentoo's website, but I am going to quickly grab it from a server on my home network. You want to get the latest version of the stage 3 tarball here though from whichever mirror you fancy like. Once you've got that, however you've got that, you can use wget to pull it down off the web if you want, just wget space URL. Then we need to extract it, so tar xpf stage3.tar.bz2. And this is now extracting pretty much the root file system with all the key components we need to be able to run a Gentoo Linux installation. So this might take a while depending on the speed of your disk. Once that's done, we can remove the stage 3 tarball that we just downloaded. Save a bit of space, and then we need to do a couple of other things. So we need to create a folder for ZFS in etc for any config related things. We want to copy over the resolve.config that we've had generated from DHCP just into our Gentoo one to use for now. We can then edit that if we want to change IP addresses, so I'm going to put Google's name servers in here for now because that's currently an issue on my home network's one. Then once that's done, we can actually get ready to use our Gentoo partition in a crew. So at the moment, /dev/proc and /sys are pointing to our rescue CD. What we want to do is also point them into /mnt/gentoo, because at the moment we've got basic stuff in there, but they are just the standard ones and they're not representative of what our actual system is. So to fix that, we do amount rebind on /dev into amount gentoo dev, amount rebind on /proc to proc, and mount rebind /sys into sys. And now if we look at sys, proc and dev, you'll see we have the correct things in there. So at this point our /mnt/gentoo won't boot, but it is a Linux system minus a kernel. Admittedly, the kernel is Linux. So it is the file system that's required to run all the applications for Linux. So what we can do is croot into it. So a chroot or croot is basically changing the current root directory of the Linux environment you're running, which can allow you to have slightly different configurations of Linux running on your system. It's how you can get Ubuntu, for example, running on a Chromebook. In effect, it's just going to change our root path to be /mnt/gentoo. So what we do here is m-i, our home directory /root, keep the terminal we're using, croot in the current directory with bash, and off we go. Bang. And so now we are in our Gentoo root. The next thing we want to do is set up some locale information quickly. So we edit etc locale.gen, and then we want to have our particular key map. So I'm engb, so engb.utf-8 utf-8. You're obviously welcome to choose any similar thing from down there, but that will do me. Then run locale-gen. For now, we'll do our time zone. So ln-sf, user share, zone info. So I'm in the UK, so I'm going to use Europe, London, and put that in etc local time. If you want to see which different time zones there are instead of Europe, London, you can just do it ls in user share, zone info. For example, are you going to be in the Antarctica in McMurdo Station? If so, there you are, there's your time zone. Once done that, we can just check what our date is at the moment. So 125 isn't quite right, BST. That's an hour out. So we need to do date, and then you do month, so 04, date, 11th, then it's hour in 24 hours, so 13, 12, 25, or 26 now, and 2017. There we are, that's then set the correct time, which we can synchronize with NTP later on. Next we want to set our host name, so etc conf.d hostname, and replace localhost in this case with guypc. Next we need to link a file in /proc/self/mounts, which shows everything that's currently mounted. Some programs look in etc mtab, so what we need to do is do a symbolic link between proc self mounts and etc mtab for compatibility. Then we need to create our fs tab, which defines what we're going to mount. Now we can just press, if you don't use nano much, you can press Ctrl K to delete lines. You can use VI, you can use whichever editor you fancy that's in here. I happen to like nano, don't shoot me for that. Then we just put in our boot EFI one here, so the FS tab is aware of it, and we also put in our swap. However, we don't put in any of the ZFS ones, as they will get mounted separately, as we'll see later on. So dev NVME 0 N1 P2 is /boot /EFI vfat defaults no auto. And it's important we have no auto there, otherwise it can mess up the directory creation and mounting at a later date. And then we do dev NVMe 0 N1 P5, P4 for swap, which doesn't get mounted to anywhere, and that is type of swap. The next thing we need to do is configure how we will build packages in Gentoo. Because Gentoo is a source-based distribution, that means we have to tell it how we want to build packages. So an important thing here is to use everything you can on your CPU. So if I do cat/proc/CPU info through grep flags, you'll see there's a whole bunch there, one for each of my CPU cores, of the different flags that are supported at compile time. So what we want to do, if we then tail lines equals 1, and do greater than flags.txt, then we edit flags.txt. If we just get all of these on one line, and hopefully these then match up directly to those that we want to use in Gentoo, with the exception of one. So if we do Control W and find PNI, this is actually SSE3 in Gentoo. So save flags.txt, and then at this point, we want to edit our portage configuration file. So portage is the packaging system for Gentoo, which makes things from source code. And what we want to do is set up how we want it to work by default. So we can edit etc portage make.conf. First thing we want to do is find these CPU flags. And where it's just got MMX, SSE, and SSE2, whilst that will definitely work with pretty much any modern CPU, it doesn't take advantage of everything that our CPU has. So we can do Control R and read in flags.txt. And then that has all of our fancy CPU flags. So some applications will benefit from that, particularly potentially maths intensive ones. Then there's a couple of other things we want to add. So we want to add input devices is evdev. I don't have a touchpad on my system. You can add a Synaptic Touch one there as well, but this would just allow me to have standard input for X when I get it installed. And video cards, I'm going to do Radeon. I've got the Intel graphics in here, which I don't normally use at all. I've got a Radeon card specifically for Linux, and I've got a NVIDIA GTX 960, which I'm not going to be using in Linux, but I'm going to be passing through to a Windows VM. So I only really want everything ready for the Radeon. So we put that in there. Then we've got more things where we can have our different culture codes. And finally, we want to specify options that always get used for make. So I have 56 cores, so it's a good idea to put the number of cores you've got plus one extra to keep stuff ticking over, because there tends to be a lot of quick start stopping compiling. So that's saying I want 57 compilation threads running at a time. Save that. Then our next step is to copy the default portage config to our local portage config. Then we can edit our portage config. And what I'm going to do now is I'm going to add a overlay into here. So an overlay can be considered like a repo. The idea is that it sits on top of the default one, and that whichever overlay has the highest precedence for a particular package is the one that you end up using. So Feared Bliss, who created the ZFS tutorial that this is based off and who's a ZFS maintainer, has got a couple of tools that are useful for ZFS. So I'm going to add his personal overlay into here. First thing I need to do is update emerge to tell all the default packages to find out where they are on the internet so that we can get a build system working. So we're going to do emerge sync. And with that done, now we can install Git. So we do emerge dev vcs /git, whack enter, and what this will do is go find all the dependencies it needs and get all the source code, unpack it all, and start compiling everything. So this is going to take a while, so we're going to do a jump cut here. So now that's done, we've got our first package installed. In fact, if we wanted to, we could do git. There we are. It might have taken a few minutes longer, but that's a lot of prerequisites sorted and out of the way now. Next thing we want to do is turn back on the support to pull in the overlay that we created with autosync. And then we can do another emerge sync, which should this time just update that package. So we're now at the point that we're ready to actually put a Linux kernel on there. Now there are a few ways that you can do this. You can build your own, you can use a Gentoo basic one. The important thing that we need to do is make sure that we've got the ZFS support within it and all of the bits that are required for it. So helpfully Feared Bliss has a kernel that's available as a binary one. Unfortunately NVMe for M2 SSDs isn't actually compiled into it, it's there as a module, which means it doesn't work out of the box with my configuration. So the easiest thing for me to do is actually create my own kernel. So we're going to go through a very basic kernel configuration. First thing we need to do is get the kernel source code. So we do that with emerge syskernel gentoo sources, and this will download the source code but not build it for a kernel. That done, we should now have the Linux source. So we can do an ls-l/user/source.linux, and we can see that that's pointing to the 4916 Gentoo one, which is the latest Gentoo Linux kernel source code as of the time of filming this. So the next thing we want to do is cd/user source Linux, and then we need to get a kernel configuration file. We can either go through this and do all of a kernel configuration ourselves, which will take a very, very, very long time, or, and also I haven't done that in about 15 years, or we can grab an existing config file. So again, Feared Bliss has got a config that works for ZFS, so we can pull that one down. So din.org, gentoo configs, config 4920. The version number doesn't matter too much, because it's a fairly recent one anyway. Excellent, then we can move the config 4920 to .config, and then what we want to do is edit.config and look for NVMe, and where we've got config NVMe core, change that from M, which is module, to Y, which is built in, and do the same for block device. Save that, then we can do make menu config, and this is where you can go through and select everything if you want by hand. What we're going to do is have a quick look in device drivers, and we can see NVMe Express block device is selected. So we can then exit. Don't need to save any changes because there were no changes that were made. And then we can do make to start building the Linux kernel. Now this one, because we're not doing the make within the portage system, we need to tell it that any parameters that are expressly useful. So on this one, something that is useful is that I want to use many CPU cores. So we can do make-j57. Then where there's any new configuration options that we haven't got in our config file, we can just press enter to accept the defaults for them. If we had saved make menu config changes, it would have added those in automatically as well. Now if you want to see what's going on, go to another terminal and you can run htop, and we can see that all of my CPU cores are being kept nice and busy at the moment. Now a kernel does take a long time to build. It takes on my system about 5 minutes, and that's with 56 cores available being kept busy. So depending on your system, you might want to go and get a cup of tea now. That's what I'm going to do. Hopefully that actually worked for you if you followed this through end to end, and if not, hopefully it's given you an indication of how much fun Gentoo can be to get up and running. I know fun could be an interesting word for some people, but I really enjoyed it. It's been a long time since I've had to compile my own kernel, so just doing that was quite fun, getting used to it and going through everything. Next time we'll be finishing all of this off and we'll be getting your Gentoo system actually booting, so please come back next week. In the meantime, let me know your thoughts on this video, whether you like it or dislike it. Please leave comments below, and if you enjoyed this video, hit subscribe so you don't miss the next part. Thanks.